Okay, folks, here we are. We are in the midst of our transformations unit. And this is our last lesson. And now we're going to pick up with vertical stretching and shrinking. For example, if you have g of x is f of, a times f of x, then what happens there is you see the a is on the outside. So it affects the graph vertically. It's a stretch by factor of a vertically. Now, if a was less than 1, it would be a shrink. I'm sorry, didn't write that very well. Sorry about that. If a is less than 1, it's a shrink. If a is greater than 1, then it's a stretch. If it's on the inside, then it's opposite of what you think. Okay? So in this situation, it would be a shrink by 1 over b. If you see a number less than 1 on the inside, say f of 1 over b, then it's a stretch by a factor of b. So when it's on the inside and being multiplied, you consider the reciprocal. So let's look at the summary of all the different things that we've looked at. We've looked at having a number multiplied on the outside. We've looked at a number subtracted on the inside. We've looked at a number added on the outside, a number multiplied on the inside. What happens is with this d value here is that this is a vertical shift, d units. And on a, on the outside, that's a vertical stretch. A units. Also, if a is positive, it's just like it would be. If a is negative, then it flips it upside down. Consider the inside. We talked about this b piece. That makes a vertical, or a horizontal, excuse me, shrink by a factor of b. And then that's a horizontal shift. Now we're not going to say c units because the b is there. You would have to factor out the b, and you would get x minus c over b. So technically it would be c over b. I just didn't change the notes to write it that way, but I think you understand it'll be a horizontal shift. So what we're going to do is I'm going to draw a function for you, f of x. And it's not going to be anything amazing as a function. It's just going to start here, go over here, and then drop down to here. So I'm just going to look at those 3 points. And we'll put one more point on there. And let's make a table of those points. The first point is -4, +1. The second point is -3, +2. The third point is 0, 2. And the final point is 3, -1. So what you want to do is you now want to graph 2f of x. And what I notice is that the 2 is on the outside. So the question, is it going to affect it vertically or horizontally? Which one? And since 2 is on the outside, it's going to affect it vertically. So what that will do is it will change the y values. So as I produce the x, y values to plot this, the x values will stay the same. -4, -3, 0, and 3. But I will multiply the y values by a factor of 2. So I get +2, +4, +4, -2. And as I go ahead and plot those, I should see the same function that I had before. Just the difference is it's stretched. Now, obviously, this graph here is larger than this graph here, but hopefully you should look at the two and see that that one is stretched. Consider the next one, f of 0.5x plus 1. So 0.5 is the same as 1/2. When you see something multiplied on the inside, you take the reciprocal of it. So the reciprocal is 2. So this isn't a horizontal shrink, it's actually a horizontal stretch. We multiply by 2. Since it's on the inside, I multiply the x values by 2. So -8, -6, 0, and 6. The +1 sits on the outside. That's going to affect the y values. So I add 1 to the y values. And as I plot that, -8, +2, -6, +3, 0, 3, and then 6, 0, it should look like the same graph. It should just be horizontally stretched by a factor of 2 and shifted up 1. Look at this one. Again, we followed it according to order of operations. You start with the inside, so we start here first, and then we go here second, and then we go here third. So you can see the -1 is on the inside. What happens with the -1? Well, that moves it right 1. So a lot of times people want to take 1 and subtract it from the x values. But if it moves it right 1, that means we add 1 to the x values. So I'm going to add 1, and I get -3, I get -2, I get 1, and I get 4. Now, the negative on the outside, that's going to impact the y values. So all the y values, I'm going to multiply by -1, and then I'm going to subtract 3. So 1 times -1 is -1, -3 is -4. 2 times -1 is -2, -3 is -5. Same thing for the next one. And then -1 times -1 is 1, -3 is -2. So I'll plot those, back 3, down 4, back 2, and down 5, over 1 and down 5, over 4 and down 2. So you can see that what we wanted from this one, there was no stretch or compression, but it was shifted right 1. It was flipped upside down vertically, and it was shifted down 3. And that's the graph. All right, the last one. We start on the inside, seeing that we have a horizontal reflection. So all the x values will become opposite. So +4, +3, 0, and -3. And then we're going to multiply the y values by 2, and then we're going to add 2. So we will, instead of this times -1 and subtract 3, we will multiply it by +2, and then we will add 2. So the first one, 1 times 2 is 2, plus 2 is 4. 2 times 2 is 4, plus 2 is 6. And -1 times 2 is -2, plus 2 is 0. So as I plot those, I should see a horizontal flip. Sorry, I messed that one up. And I should see a stretch. So it does look like it's flipped the other way, and it looks like it is stretched by a factor of 2. So there you have it. So be ready to look at these type of examples where you understand what to do. So again, in this situation, this was a vertical stretch by a factor of 2. For the second one, it was a horizontal stretch by a factor of 2, and then a vertical shift up 1. This was a shift right 1, a vertical flip, and then a shift down 3. And then this last one was a horizontal flip, a vertical stretch by a factor of 2, and finally a vertical shift up 2 units. The last thing I want to talk about are even and odd functions. Here's an example of an odd function. Y is equal to x cubed. And an odd function is one that is symmetrical about the origin. And what that means is whatever you see in the first quadrant, you'd see it reproduced in the third quadrant. If you were to rotate this thing 180 degrees, you would get the same thing. Symmetrical about the origin. Now, if you notice, you can see that it says odd as the exponent is odd. So that's a good way to tell whether it's going to be odd or even. But not all functions can you do that with. For example, y equals the sine of x, that is an odd function. You guys don't know what it looks like yet, but that is an odd function. You don't really see an exponent on it, so it's tough to tell. Whereas y equals cosine of x, that's an even function. Now, here's the test that we use. If f of negative x is equal to negative f of x, then it is an odd function. So let's look at this first example here. It says determine if the following functions are odd, even, or neither. And you should be able to do it two ways. Number one, you should be able to look at it and see you have an exponent of 3 and an exponent of 1. Those are both odd, so this should be odd. But on the test, you will need to show that they are odd. And what we do is we use this. We do f of negative x. And what we get is if you plug in a negative x and cube it, and then minus 4 times negative x. We plug in a negative x, and let's see what result we get. Negative x cubed is simply negative x cubed, and then plus 4x. Is that the same as what we started with? No. But if we factor out a negative, we get positive x cubed minus 4x. Notice this thing right here, that is f of x. So you've come up with negative f of x. And that's our definition. F of negative x is negative f of x. And so we've shown that to be true. Even functions. An even function would be, say, y is equal to x squared. If you look at that, it is symmetrical about the y-axis. The test for it is f of negative x produces f of x. Let's see how that works. Look at letter B. In letter B, you have an exponent of 2, and then you have 10. That means 10x to the 0 power, because anything to the 0 power is 1. So both those exponents are even. 2 and 0 are considered even. So let's do our test. F of negative x. Negative, parenthesis, negative x squared plus 10. Notice when we square negative x, we get positive x. And then you attach the negative out front, and we get that. Is that the same as what we started with? It is. And so you have shown that f of negative x is the same as f of x. So therefore, it is even. So we have odd. Oh, my smart board just went a little bit crazy. Wait for it to calm down here. So this is odd. This is even. Now the last one, I forget to change this every year. We're going to make it x. As you look, your exponents are 4, 2, and 1. So they're not all odd, and they're not all even. So you can tell that this one should be neither. Let's confirm that. f of negative x. We get negative x quantity to the fourth minus negative x quantity squared plus negative x. When we use up our exponents there, a negative to the fourth will be positive, so positive x to the fourth, and then plus x squared. I'm sorry, minus x squared. And then it's a minus x. The question is that the same as what we started with? No, it's not. Try factoring out a negative. Negative x to the fourth plus x squared plus x. Is that the same as what we started with? No, it's not. So it is neither even nor odd. And that finishes kind of our focus on even and odd functions. Remember, you should be able to look at the graph, like say this one, absolute value of x, is that even or odd? It's even because it's symmetrical about the y-axis. Whereas say the graph of y equals x, hopefully you can look at that and say it's odd because it's symmetrical about the origin. So there you have it, folks. Hopefully that helps, and look forward to any questions you have and see you in class.